Going to create a circuit using Arduino Uno, piezo speaker and a potentiometer to create the sound which is used in the Super Mario game. So for this I am going to first bring in an Arduino Uno into the workspace. Next I am going to bring in a potentiometer, a resistor and a piezo speaker into the space. So for this particular circuit I am not going to use the breadboard. So over here what I'll do is I'll connect the pin number 4 to the resistor, which I will connect to this particular wiper, and then I'll connect the potentiometer to one of the terminals, and the second terminal I am going to connect to the ground. Okay. So this is the circuit. So the ground I am going to put it in black, and then this one and this one I am going to put it in red. So all of this will be red. Alright. Next let us write the code for this. Now as such the circuit per se is very straightforward over here. Now for the code, this is a set code which I got from online, so I'm just going to put it on. So what we will do is first we'll play the speaker on pin number 4 with tune 64 for 0.1 second, and then wait for 0.15 seconds. Next we are going to play the speaker once again on pin number 4, the tune 64 for 0.1 second, then wait for 0.3 seconds. So this actually corresponds to the tune for the Super Mario game. Next, play the speaker which is on pin number 4, once again tune 64 for 0.1 second, wait for 0.3 seconds this time, no, correct, 0.3 seconds, and then for the next time play tune number 60. Earlier it was 64, now tune number 60 for 0.1 seconds, and then wait for 0.1 second, and then play tune 64, pin 4, tune 64 for 0.1 second, and then wait for 0.3 seconds. Play the speaker on pin 4 for just a second, for 0.1 second, and then sorry, this is 67 for 0.1 second, and then wait for 0.55 seconds. We are coming to the end of this particular tune now. Then pin number 4, play 55, tune number 55 for 0.1 second, and then wait for 2 seconds. So this should create the tune for the Super Mario game. Alright, let's see whether this is going to work or not. Here we go. Hey, great. So it is working. Alright, so now you please go ahead and try to replicate this. So what we can do is, so you can rotate this and you can see that the sound reduces by quite a bit. So 5 kilo ohms is actually quite a bit. So instead of 5, oh, this was 250. Okay. So let's rerun this. So you can see that you can use the potentiometer in order to reduce the sound. Now I'm going to stop this. You can see what exactly is happening, what is the signal which is being given to the speaker. So in order to see the signal, what you can do is you can connect a oscilloscope over here. So go to all, bring in the oscilloscope, resize this. Now okay, I think any side is okay. Alright, so let me take per division as actually 1 millisecond. This is just to show you the, or 10 milliseconds. This is just to show you the kind of signal which is being input to the piezo speaker. So alright, so one terminal, it is connected to the negative, and another terminal it is connected. Okay, sorry, let's just connect. So alright, so this positive terminal, let us connect it to the positive here, and the negative terminal, let us connect it to the negative over here. Okay, now let us rerun the simulation. Alright, let's restart it. Okay, so you can't really see anything, so we'll have to reduce the time per division to this. So now you can see the pulse width modulated signal which is being given to the speaker. So please note that each of these boxes is 10 milliseconds. Sorry, this whole range is 10 milliseconds for the x-axis, and for the y-axis it is 4 volts. So you can see that the voltage which is being given to the piezo is about 2 volts. Alright, so you please try to replicate this.